In this lesson, we're looking at properties of rectangles. There are 5 examples, including 2 for you to try on your own. So let's go ahead and get into the lesson. Of course, rectangles have the same properties as parallelograms. The opposite sides are congruent. So draw some congruence marks here. All right, opposite sides are also parallel. Draw these parallel marks here. All right, opposite angles are congruent. All right. Consecutive angles are supplementary, meaning they equal 180. So angles C and B equal 180. These are angles B and A and D 180, and D and C. So they're supplementary, so they equal 180, and diagonals bisect each other, so they cut each other in half equally. So these 2 segments will be congruent as well as these 2. Now also, a rectangle has 4 right angles, so of course it meets the criteria for a parallelogram because the opposite angles are congruent. Not only are they congruent, but they are the same because all 4 angles equal 90 degrees, and the diagonals are congruent. So not only do they bisect each other, they are also congruent. So if diagonal DB, for example, is 10, then diagonal AC is also 10. So those are your properties for rectangles. So they're properties of parallelograms, but you're adding the 2 properties here where you have the 4 right angles and the congruent diagonals. So let's use our knowledge of properties of rectangles to find the measures of each of these sides noted here. First, I just want to label that SR will also be 24 and QR will be 10 because in a rectangle, opposite sides are congruent. So QR would be 10 and SR would be 24. Now SQ is a diagonal, and I don't have the length for the diagonal, but I do have a right triangle right here because all 4 sides or all 4 angles in a rectangle are right triangles. And so since I have a right triangle here, I could use the Pythagorean theorem, a squared plus b squared equals c squared, to solve for SQ. SQ would be the hypotenuse of this triangle because it would be opposite the right angle. Okay, so A and B, of course, would be my legs. That would be 24 squared plus 10 squared is equal to, it's either c squared or you could say SQ squared because c would be my hypotenuse. So 24 squared plus 10 squared. That would give me 676 equals c squared. Just solving, taking the square root. C is 26. So this is 26. So since PR is a diagonal, remember diagonals are also congruent in a rectangle. PR will also be 26. And QT, the diagonals also bisect each other because remember a rectangle is also a parallelogram. So each one of these lengths, PT, TQ, TS, all of them will be 13. So QT would be 13. And so we found the measure of each one of these segments here. So in this problem here, we want to find VT. We're given RT, which is 5x minus 14, and US is 2x plus 10. RT and US are both diagonals, right? They're diagonals, and what do we know about diagonals of a rectangle? They are congruent, meaning they have the same length. And so we could find S or X by setting these 2 expressions equal to each other. So 5x minus 14 is equal to 2x plus 10. Just solving this equation here using algebra skills. Combining like terms by doing inverse operations. Subtracting 2x, I get 3x minus 14. Adding 14, because I'm left with that two-step equation. 3x is equal to 24. X is equal to 8. So I'm not done. I have to find VT. So I want to plug it back in. I could plug it into either RT or US because they are congruent. But I'm going to plug it into RT. So RT is equal to 5x minus 14. Plugging that in, 5 times 8 is 40. Yes, minus 14, that is 26. I still haven't found RT. So VT. So RT is 26, right? But I'm looking for VT, and so that would be half, because diagonals also bisect each other, so they cut each other in half. So if the entire length of RT is 26, each side would be 13. So VT is equal to 13. For this example, I would like for you to try it on your own. Go ahead and pause the video, analyze what you know about properties of rectangles, solve for x, and then find the length of WT. So go ahead and pause and try this problem. Okay, so WT is 34. Hopefully you got it correct. The reason we multiplied by 2 is because we were given VW. VW is 9x minus 11. Therefore, WT would be 9x minus 11. So we would just multiply that by 2. Or you could have taken half of SU and set it equal to 9x minus 11. And then just plug in x. Either way, you would have gotten the same answer. Hopefully you got it correct. If not, go ahead and just pause the video and analyze this work just a little more. For this example here, we're looking for the measure of angle JHI. Angle JHI is right here. I'm coloring it purple right here. And so, of course, we want to find the value of x. Well, what do we know about rectangles? We know about, or what do we know about the angles of each rectangle? Well, all the angles are equal to 90. So to find x, I could set these two expressions equal to 90, or their sum. So that would be 3x plus 2 plus the 12x minus 17. Both of these together would be equal to 90 degrees. Now I'm just going to solve for x. So 3x plus 12x, 15x, 2 minus 17, negative 15 equals 90. I'm left with that two-step equation using inverse operations to add my like terms, or combine my like terms, and dividing through by 15. So x is 105 divided by 15. So x is 7. So I need to find JHI. I don't have anything right here, but what I do have, I have the alternate interior angle to angle JHI, which is angle GJH, which is here. Angle GJH. These are alternate interior angles, meaning they would be also have the same measure. So if I just plug in 7 here, I could get the measure of JHI. So 3 times 7 plus 2, 21 plus 2, that is 23. So the measure of this angle here would be 23. So the alternate interior angle would be 23 as well. So the measure of angle JHI is 23 degrees. Let's just take this problem a little further. If we know that this angle is 23, the measure of angle HJI would be, they would complement each other, meaning they would equal 90. So this will have to be 67, because I just subtract 90 minus 67. And we could take it a little further. If we plug in x here, 12 times 7 minus 17. 84 minus 17 does in fact give me 67, so it works out. But so just took that problem a little further, but we found our answer, which is 23 for this problem. All right, so we reached our last example. I would like for you to actually try this problem on your own. So go ahead and pause the video and try this problem on your own. The measure of angle BCE is 71 degrees. Hopefully you got it correct. The angles that you were given were alternate interior angles, which is why the expressions were set equal to each other. Plugging in x, we get 19, but that is for DC, measure of angle DCE, which is 19. And how do we get the 71? Of course, we subtracted that from 90 because this is a right angle. And we get 71 degrees, but hopefully you got it correct. If not, maybe pause the video and analyze the work here a little bit more. We reached the end of our lesson. I want to thank you for learning with me. Some related videos are perimeter of polygons using coordinates and properties of rectangles. If you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.